Hello everybody and welcome to another episode of No Orientation Programming. I'm Joe and today we will hopefully send an email from our administration application. Last time we implemented parts of the API for creating processes inside the administration application. And it's almost done. Let's see. I wanted to create another function that is called success. Yes. Because we need this multiple time. We call this poo. A dproc check, I don't know. And this function just diff, yes. This function does the base check of the ID proc. Stuff. Is this function useful? ID proc current. We need this function multiple times, proc find, and I want to eliminate these lines of code. It seems to be quite useless, but I think it's fine, because we need these lines at least 3 times. So success is equal to that if success not equal to positive, then break, just break, because I want to set the state. The state is set in here, I think, because we have generated an error. And this function just checks the member ID proc. We then can remove the lines here as well if we repel the process. Proc find. Yes. I think that's fine. And we need this function here as well. With this API, we can create a process in the administration application, and then we can, if we create the if we have created a process, then we get a process ID, and with this ID we can control the process. We can check if it's done. We can repel the process, cleaning it up, and we can get the result. And for these 3 commands, we can use the ID proc check. Of course, we also have to find the process if we want to get the result. And then let's for response. Result process is pproc result. Let's see what this is doing. Yes, of course. Yes, of course. We can't return here because we don't want the state machine to go down. That's fine. Yes. Okay. So let's see. We don't have a process at the moment, but we can create one with account create. This process failed immediately because it's not implemented yet, and we can repel this process, so we can clean it up. We can create another one, and then we can check TGSA success. What do we get? We get a positive success for the command. We get a negative success of the process. Why? The reason is missing field receive. That's cool. Now, we create another script. And the script should execute the command result, and let's see what we have here. TGSA result of the current process. Okay. we have saved the reason in here. What if we don't, if we have a account create? Yes, it's still running. Result is null. Okay. Mm-hmm. Okay. I think that's fine. That's cool. Null. Is this a valid JSON file? Yes, it is. Okay, fine. Okay, then this is fine. Okay. I'm fine with that. So, okay, then we have that's cool. Success. Yes, success of the process is 0. That means it's pending. The success is pending. Let's try something else. Return positive. We create the account. Nice, fine. We get it success 1, that's fine. We try to get the result. That's fine as well. And we repel this thing. It's gone. Nice. So one last test. One last test. We create the process. We check the success pending. We try to get the result. And we repel this thing. Perfect. So the API is fine. Yes, and that's it. Okay. Okay, bash, wait for milliseconds. Always. Okay, that's fine. So, yes, the create function, the create script should create something. No, I think the create function is useless, in fact. So we can remove it. We have concrete, yes, we have concrete create functions. And yes, okay. We have one repel function for everything. Yes, that's because we get the ID. We have a result. These three functions are global. Repel, result, and success. Success is the first one that gets executed after an create. Then the result, and then the repel function. And the account create function, the script, the account create script should. So success is fine. Account create. Create a function, a process. This account creating script, we have to distinguish between creation of the account and creation of the process. This account creation script does three things. First, create the process account creating. That is, we remove the current ID. We have a command and we have a response. If the response of this specific create command is not successful, then go out. Let's try something. I want to make this a little bit more beautiful. Account create. Yes, why do I see the response? I don't want to see the response. Yes. Okay, that's fine. But if we have an unknown command, then we exit at this point and we want to for a moment I want to re-enable the response because reason command, yes. Yes, that's fine for me at this point. Is it? Yes, that's fine. Reason command. So in case of an error, we extract the reason and then we print it. Echo could not create process account creating. The reason is this. This is similar to what we get in the source code of the client, the gaming server. And now we should get could not create process account creating reason. Let's make it a little bit more beautiful. Echo. Could not create process. Cool. So this was the first step. And now we want to make the second step. And the second step is wait for the process to finish. Because this API allows us to we have two choices. We have a choice we have to make. If we make the API simpler, for example, we could just implement a function that is called account creating and which is synchronized. That means it's blocking. We could do that, but then we would need to have an open connection as long as the process in the server is running. And I want to avoid this. I want to create a short connection, create something that may take more time, So we create a process that takes a lot of time, and we can shut down the connection every time. That's the plan. So I think we can say while true. I don't know. A while loop. I think this is the. Can we make a break? I don't want to look it up. It's so embarrassing. While true. Shell check. This is a very useful application. Shell check. TGSA account create. Is this working as well? Seems to be working. Okay. We have to fix this. Test 1. Oh, that's cool. Yeah, it's working. Fine. Okay, so now we need a different command, and this command, yes, is tgsa success, and this, yes, function is success command. No, wait, yes, fine. We create a variable that's called success, and this variable is tgsa success of the ID of the process no such file or directory. Okay, that is if we have the file then the ID is this. If not 0 the first argument, then now we should get only these 4 lines, hopefully. Yes, that's cool. Now we can optionally I want to make it a little bit different. Elif. If this is not 0, then try to get the current ID from this thing, and otherwise we could say else not specified. Process ID not specified, that's fine. Yes, that's fine, that's cool. Yes, that's cool. Yeah, that's fine for me. Okay. We specify the ID of the process. Now we have saved the variable. CPP, interesting. High octaelliptical. We call this response instead. Yes. What are you working on? Today everybody is coding in Rust. So I'm a dinosaur, a C++ dinosaur, and I'm not even coding in modern C++, but in ancient C++. I forgot to change the title to ancient C++. Thanks for the follow. I'm working on a multiplayer terminal game server that is... Oh, no. Between modern and ancient C++. I don't know actually. Many people say they are coding in modern C++ and that is using the more recent versions of C++ and standards, the new standards. I'm using C++ 11, but only because of one reason. Actually, I could use the oldest version, so I don't have all the fancy stuff. Yes, C++ 20, yes, many people use 20, and there are many good reasons to do so, but I try to make this stuff in 11, and this is how far we have. Oh, curl global cleanup. Yes, I have changed. One moment. This is not the big bug. Lib global cleanup. Where is the global cleanup? Undefined. Yes. Because of this, I need to add in the Mason file this dependency. Oh, the hell is going on? The curl dependency. Now it should work. Now it should compile. Yes, fine. That's cool. And now we can connect to the server. So this is the gaming server application, and you can connect to the application with Telnet. Actually, you can connect from external stuff as well. Testing USTO, I think. So if you type in Telnet Naegulus testing USTO 4000, then you should be able to connect, and we could play Connect 4 together. So this is the project. And if you connect at this moment of the game, you are connecting as a spectator. And yes, if you connect during the lobbying process, then we could assign teams to each other and we could play against each other. And this is quite cool already. And this game will have, so I have one, for example, and then we have a timer. It's showing the result, and after that we go back to the lobby, and I can assign teams. I can go to team 1 or 2, and that's it. You have a menu, and yes, the version history, licenses, stuff. So this will be a game server, a terminal game server where people can play multiplayer games, and the lobby, as you can see, the lobby is very minimalistic. So the lobby is very simple, and it's planned that the lobby gets a lot bigger with a chat, with a page where you can set game options like maps, levels, difficulty of the AI and stuff. And because we want to have a chat, we need something different, something else as well, that is a system that allows us to create user accounts. Because if you connect with Telnet, this is a Telnet client, but Telnet is a protocol that sends all the data in clear text, so nothing is secured. And because of that, in the server, I don't force the user to input a password or any other sensitive data. So if you use the Telnet client, then you connect as a guest and you get a random gamer name, and guests will not be able to use the chat because because of the spam stuff. Everybody could connect and type in some strange stuff, and because of that we have another mechanism that is SSH. SSH is like Telnet but encrypted, and you can connect with SSH as well. Localhost 4000 in at port. What? Why? What? Net.ntl. Why? Ah, I'm so stupid. the command is different. Yes, I know. The port must be 4001, and then I can say foo, I can say localhost, and we have implemented an SSH server as well, so you can connect with an SSH client, and let's say we type a password. Then we have created a page where you can authorize yourself, authenticate yourself, and you get an authorization process, and it's logging you into the system. So and this is where we are at the moment. We have a second application, and this second application is called the administration application. And these two applications communicate with each other. So we have the game server. On the game server, some people are connecting, and if a user connects to the gaming server, then the gaming server has to ask the administration server is this user fine or not? And to communicate with this administration application, we have implemented an API to create processes inside the administration application. And these processes then check in a database or whatever, is this a valid user? And then the gaming server can get the results. And the API is finished already, and now I'm writing on the test scripts. And the test scripts, for example, we have an account creating function or process, and the gaming server requests the creation of a process that is called account creating. So we want to create an account creating process, and the administration server gives us the answer, yes, okay, fine. We have a process view in the administration application, and the process view, let's restart the application so I can show you what's going on. If I execute the script, then a process is created that is called account creating, and this process is sending an email, which we will specify later. But as you can see, the process is running at the moment. It's not progressing because it's not implemented yet, but because it's created, we can check the state of the process inside the admin app, and the admin app that's called TGSA. TGS is Terminal Game Server. How long did it took for you guys to make this? Actually, not that much time, because I'm alone as a dev. This whole project has a different purpose, and the purpose is testing the core file, and the core file is called processing CPP, and this file is quite cool, I think. And this the purpose of this project is to test this class, and one function of this class should be to be able to create complex systems in a very short time, and at the moment I think it's quite fine, because we have started this project, I think, in we can check in the history file, telnet. We can see in the history file when this project has started, version history, and go down. It has started in September 2020, 3 months ago, and I'm only coding in 6 hours a week, 3 hours on Tuesday and 3 hours at Thursday, and I have 3 or 4 days additionally for the SSH server. The SSH server implementation was not streamed. It was a little bit more fancy. So this is the time it took. So 3 months times 4 weeks. Let's see. 3 months times 4 weeks times 2 days times 3 hours. Yes, 80 hours or 100 hours at the moment. So 2 or 3 weeks, I think, in total. So I think it's quite efficient. And that's because the structure of the software is very simple. It's always the same, no matter at which position in the system. No matter where you are, we always have a state machine. It's very simple C++, and so these are all simple things, and that's quite cool. So the goal for today, I don't know if we can reach the goal for today, because the goal would be to send an email to our account, but I think I have to fine-tune the API, I guess. This test script, the account creating thing, is using the other scripts. For example, it's calling the process, the script TGSA, that's the administration application, TGSA, Terminal Game Server Administration. And this result will give us, so the TGSA gives us a response that is a JSON in JSON format, and it's returning 2 fields. The first field is, was this command successful? Yes, it was. The second field is the process you have created. In this case, the account creating process is in which state is this process, and 0 means pending. It's not finished yet, as we can see here in the process view. And in the test script, I want to wait until the process has finished. And that is, first I have to check if the command has succeeded. I will make another script, a helper script, and that is called libtgsa.sh, and this thing should make a function. How can I make a function in Bash? I have forgotten how to make a function in Bash. I think just error print like this, hopefully. And then I can source the file libtgsa.sh, and if not successful, then yes, response is equal to the first parameter. Reason command. Reason command hi. If 0 so we have a response and this response. Oh, come on. I think this should work. Yes, I think that's fine. If we have a high-level reason, then error reason high level. I can simplify this stuff, saying error if this is not 0, then make a high level message, otherwise at least we have a low level reason. I think this should be it. Let's check. I make a bug here. The command should not be known, should be unknown. And yes, fine, that's cool. We try to create with this script, we try to create a error code not execute command. Why? Reason could not create process, low level reason, unknown command, account creating. Yeah, that's cool. And now we can reuse this error printing function at this point. So if this success command failed because of some reason, maybe the ID was wrong, then we have to return. Otherwise, we have successfully we got an answer, a valid answer, and the valid answer in this case should be the success of the process. So we have a different variable that's called success process. And this variable should tell us if we are finished or not. That is, if success of the process is equal to 0, that is pending, then continue. If it has finished, then we have to check if If this is not equal to positive, if the process, at this point the process has finished. If the process hasn't finished, if it's pending, then wait. We have to be careful. We have to make a sleep. Yes, that's fine. So we execute the process, we sleep at least 100 milliseconds. In this case, it's quite inefficient, but it doesn't matter because on the other hand, it's quite cool. After 100 milliseconds, the process should be finished very likely. So we just have one iteration. We get the response, the success of the process. If the command itself had no error, then we can check the state of the process. If the process is still running, then try again, wait, and then try again. If the result is not positive, then we say echo process error at first, whatever. Otherwise, we can break from the loop. So we have at the moment we just say process finished successfully. Okay. So now we have to change the process doing something. We create this thing, could not execute command. Why? Yes, because I did not fix this typo. That's cool. Now we should get the process has yes, fine. Now we should get this message, process error. Yes, that's cool. That's cool. Process error. Let's print echo the response. Yes, that's cool. So we make a different function that is called error process print. Error could not finish process. Error during process, whatever. Don't know. We don't have reason process. Reason process is, oh, come on. So we don't have a high level reason at the moment. Error during process execution, whatever, reason. Okay. Error during process execution. Yeah, fine. Let's try to see. Could not execute command. Why? Oh, reason high level. Why reason command? What the? Okay, let's test something. Oh, this is the gaming server. Cut temp JSON. Yes, fine. Let's make jQ dot -r point. Yes, and then we say test. Ah, it's returning null. Ah, come on. If I hope this is working, is not equal to null. Yes, that's cool. That's fine. Okay, that's working. So if we extract a non-existing element from the JSON with the JSON query application, then the result is not an empty string, but a string that contains null. Okay, that's fine. So we have too many processes. That's fine. Yeah, nice, perfect. Oh, that's cool. So we create the process in the test script. We create the process account creating, as you can see in the process tree. Then we wait until this process has finished. So we execute potentially multiple times the subscript TGSA success. We did not get any command error, which is what we expect. Then we can, if we don't have a command error, then we can consumer check the success of the process field, the success of the process. We saw that the process is not pending, so we got here, and we saw that the process was not finished successfully, and because of that we print the error process during process execution, reason missing field, receive. So if we create the process, every process has its arguments, and the process will check if it has everything it needs that is in its state machine, account creating state machine. At first, the process is checking if the JSON arguments contain a variable that is called receiver. If we don't have an receiver email, then we cannot send anything. So the process returns and ends with a specific error, and this error is stored in its result JSON. And the command processing process sends this result to us if we ask for it. In this case, we executed this, the command, the API command. Success, give me the success of the process, and the server is telling us you have created a process, but this process failed. And this is the error from the process, from the internal process. So this error message is generated in this process, and because we asked for it, this process gave us sent us the error message, and that's cool. That's quite cool. As you can see here, and this is the log of the administration application. At first, we have sent this command, account create, the command create. What should we create? A process that is called account creating with the arguments 0. Creating the process was fine, so it returned success command positive 1, and the ID of the process. We the ID, we have to use the ID for all subsequent commands. And then we wanted to know the success. This is the command, give me the success of the process with the process ID 0. And the response was, the success of the command is 1. I have successfully interpreted the command itself, so this is fine, but your process with this ID was not successful, and the reason is missing field. That's cool. That's exactly what we want. So now we test what happens if positive, if the process, this process isn't implemented yet, and what we test what happens if the process returns positive. Then, as you can see, this x means not positive, and this plus means yes, the process has finished successfully, and now we see the message, process finished successfully. This is the account creation, the input, the output of the command. This is the input of the command, give me the success of process 0, and this is the output of the command. Now we have success of the command is positive, and success of the process itself is positive as well. And this is the difference now. That's cool. I don't know why, but I like bash scripting. Bash scripting is kind of cool. Okay, so I hope I don't need this helper script anymore. Okay, so, and what do we do if we have finished the process successfully? Then we want to print its result. Yes, wait for the process to finish, then we consume the result, and then we repel the process. But we also have to execute the repel function in case of an error. That is, so let's see. Yes. So we go back to the first behavior. The result is creating the error. That's fine. And we want to display this error to the user. That's fine. So we execute the process, and as soon as it has finished, we want to know this state from the command processing thing. As soon as this process has finished, we consume its result, and in this case, consuming the result means displaying the error, or what means weiterleiten? Come on. To pass. Consuming the result of the process in this case means passing the error message to the client of the administration tool. We have done this, but so this script is finished. As you can see, the script is finished, but the process on the administration server is still in the list. So this is called a zombie process. We have to inform the command processing, the server, the administration server, that we have successfully extracted the result of the process and it is able to delete the process. And for this, we have another script that is called tgsa repel. Repel our process with the ID of the process. I hope this is working. So let's try to repel this process, in this case manually. If I pass 0, then it gets deleted. That's fine. And now I want to make the account creation thing. Yes, that's cool. I don't want to repel. I don't want to print the result. Yes. Okay, one moment. So the response is always this. Yes, and I don't want to print the result. Okay. So, as you can see, now a lot of stuff is happening already. The administration server has a listening process which is executing user processes. So it's listening to commands, and we have an API. The script creates a process. The process inside the administration application is running. It's doing something, hopefully successfully. And eventually it has finished. And as soon as it has finished, as long as it's running, we always execute what is your success. Are you still pending? Are you still executing? If the process has finished, as soon as the process has finished, we detect in our script this at that point. If we got an error, then we display, we pass on the error message, and then we have to repel the process. That means, repelling means I do not consume any other information from the process. The result, the consumption of the result is done, and we can clean up the process. And for that, we send in the repel function, we have we see this here. We want to repel something, a process with the ID 2. As you can see, the ID, the process ID is incremented. So the next process gets the next higher ID, the incremented ID 3. We can see this here, create the process. Yes, successful, you got the process ID 3. Then we check the state of the process, success of process ID 3. Command is successful, but the process is not successful. It has an error, and the reason is missing field receive. And then we say, okay, I gave this information to the user. We print it on the terminal, and the next step is to repel the process. So this is quite cool already. We have to do this in case of an error, as well as in case of everything went fine. In the error case, we consume the result by printing an error message. Otherwise, we print the result, and that is result proc. Yep. Result proc is that. Yes, that's the success of the process, and now we want to print the result and the process. Yes. Cool. Let's try this. Okay, it's still failing. That's fine. Now we want to. Come on. Yep. So we are recompiling. The process should finish successfully now. Yes, process finished successfully. We have cleaned up the process, and the process result is null because it's null. Let's try to store something into the result, like foo bar. Come on. This wasn't intended. No, yes, of course. Because we do not get the result from the success command, but from the result command, and that is TGA result. So we get the result with this command. This is the API here. This thing, we have 4 stages: creation, waiting, and then evaluation in 2 steps. The first is getting the result, and this fourth or second stage in the evaluation stage is repelling the process. So this is the third step, getting the result of a specific ID. We have to check, of course, again, the success of the command itself. Because let's try to get the that's interesting. Let's try to this could crash the server. Let's see if this is crashing. Finished successfully. Yeah. Yep. Nope. This is not expected at the moment because this thing should create an error. Let's see. Okay. No. Yes, this is the ID. What happens if I send the ID A? Then we should get an error. Do I see this in the log? I see success, fine. Result of 0 by 0. And then the result again. So somehow this gets converted to 0. Result ID. Yes, because I've forgotten to implement. Oh, yes, and this here as well. One moment. So, process ID not specified. Yes, that's fine. Repel. Success. We want to have an output for success. We don't want to have an output for repel. That's fine. And we want to have an output for this one. That's fine as well. Yes, that's cool. Yes, now it should be working. Working means that I expect an error. Yes, the process finished successfully, but as you can see, we did not repel this thing. Oh yes, that's important, because now we have a process. Even if we have an error for the command, we have to repel the process. Okay, let's see. TGSA repel. Yes, fine. So if I create the account, yes, that's cool. The process has finished successfully. But during getting the result, repel the process. If we have, for some reason, if we have an error at the command result, then we still have to clean up the process. So, and if I remove this line, then the result function gets a proper ID, and there shouldn't be any error during the success command. During the result command. This is the result command, and the success of the command should be positive. So we should be able to extract the result of the process finally. So yes, that's cool. Yeah, nice. Step by step. This is just step by step. So this is cool. The process finished successfully. We don't want to print this message in the end. So this is fine. We only get the result. And the result is generated inside the system in the account creating process. And that's fine and cool. So I think we have finished the API. The implementation of the API took 4.5 hours. Last time we started creating the API, and that's cool. We have two applications. That the administration application has a running API. That's cool. At the moment, we are using this API through Bash scripts. Later on, we have to implement the client side of this API. That is a process that is running in the game server. In the game server, we want to use this API, so we will create a process that can communicate with the administration process. So this is fine and cool. This is done. And now that's cool. Yeah, we have 1.5 hours left. To implement this thing. Okay, so we say the receiver is equal to some test mail, let's say office@dsbcrowd.com. If the argument is not, the first argument is not 0, then set the receiver to the first argument and add this receiver argument to the JSON, to the part of the JSON where we have the arguments. I think this is it. So now that this account creating process should not complain anymore about a missing field. It should create a mail sending process it should then send the recipient, the receiver. This is done here. To do set configure mail sending process. This is not implemented at the moment. It should start the process. The mail sending process has its own state machine. As you can see, this is completely the same structure. And the command processing process also has the same structure. But we go down into the system, in the hierarchy of the system. We have implemented this thing. This is this process is giving us the function of an API, and now we have implemented the API. We can go one step down in the hierarchy. So I think we can close this thing at the moment, and we don't need the main thing. That's cool. The main process. So now if we compile the server, then we should see in the repel function. I make a temporary thing, and that is if the second argument is 0, then I want to exit and call and say disabled. I don't want to repel. I don't want to repel the processes in the scripts, but I want to be able to repel the processes manually. So if I create a process, then this thing will not be this script will be stuck in this while loop, because the process is not returning. So let's see. The expectation is that this script will be stuck. Yes. We are always checking for it for the success of the process, but it is not finishing. That's cool. So I stop this script. The script in a while loop always executes the command, give me the success of the process with the process ID 0, and the return of the server is, I have understood your command, but the process is still running. So the success of the process is pending. And as you can see, we have an account creating process, and this account creating process is using a mail sending process. Now we will implement this mail sending process, and the function of the mail sending process is as input we have mail addresses, and the output is that a mail has been sent. And then we have our piece. Okay, so what kind of functions do we need? The cool thing, the very cool thing is that we can use something that is called libcurl. And libcurl is a very cool library which is able to send HTTP requests. And the cool thing is it is also able to send SMTP requests. That is simple mail transfer protocol requests. SMTP. SMTP. Simple mail transfer protocol. And it is also able to make this over SSL, and that's very important nowadays. What is Stateless? Let's read this in English. But at the moment, okay, so Stateless is obsolete. It seems. So we should use SSL, and we can use SSL in libcurl as well, and that's very cool. So we have an encrypted mail sending library, and with an MIT license. The license is very important. So this is the German word eierlegende Wollmilchsau. I need to... Oh, there is no English entry for this eierlegende Wollmilchsau. It's an egg-laying wool milk pig. Eierlegende Wollmilchsau. So this is this means we have a complete package of a very cool thing, and we will use this thing. And I already have an HTTP request class. That is very cool. So I will try to mimic this thing a little bit. So we will have some functions that is void recipient der Empfänger, der recipient set, and we have come on. The member functions. Yes. I think here it's fine. It's very interesting. Nobody's using this using namespace std. I seem to be the only one who is using this. I think all the others consider this a bad coding style. So we are coding bad code. That's fine. And I want a variable that has STD string m recipient address and m recipient name. And these two variables, these are process states, and these variables will be initialized here and set in this function. It's cool. Then we need another function that is called sender set. Sender. Sometimes I can't decide how I want to call my stuff. Naming is very hard in programming. It's a very hard task. So we have a recipient and a sender, and as we have these two things for the server as well. Sender, not server. That's fine. What do we next? What do we need next? We need a subject. Subject set. Subject. And we need a content or body. 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 Okay. And std gets deleted. That's perfect. And now we have a subject and a body. That's cool. These two functions are easy to implement. Subject is equal to subject, and body is the body. That's cool. Let's try to compile this for a moment. Oh, come on. Yeah, unused parameter. Yes, of course. Wait. Sender. Cool. So we have a sender, a receiver. Okay. And yes, we have. Okay. Now we have the tools, and there should be. Yes, this is the not TGSA. This is curl. Yes, fine. And we have a curl thing, a curl command that is URL. Okay, yes, we have an URL. Oh, come on, URL. I don't want to use URL, but I want to say void server set. Server, and optionally a port, but the port will be, yes, we don't implement the port at the moment because server int 16 port. This port will be initialized with 465. Because this should stay the same in general. We only implement the very functions we need. And that is the functions we need to make this process, so the process makes sense. We will change the server, of course. We will change, very likely we will change the server. If we have a hard-coded server, then this mail sending process is very limited to one server. So we have a function for that. The sender and the recipient will be changing very likely the subject and the body as well, but the port is not that important at the moment, so we can just keep it hard-coded. And that's fine. Okay. Yes, so because this function is on top, the variable names should be on top as well. So we have the server, we have the peers, and we have the mail itself. Subject and body. That's fine. Okay, you're cool. And now we will change something that is mail. Oh, come on. No, come on. Go close the thing. Yes, this is not the real password. This is not the real password. So we have, oh, what the hell is going on? Oh, come on. Oh, come on. Okay, so, whatever. So, now we have to configure this stuff. Create the configuration, and that is mpmail. Server set recipient set is m arguments the receiver. Recipient. Okay. Recipient. Okay, now this thing should not complain. Dot as string. So now we have set the recipient. The sender is you get the mail from the system. The subject is Okay, I think this is it. And the subject is stored in our file, and this is it. Okay, I think. I don't want to include this header in the text file, but I want it to be like this. This is the resource file, and this is a valid body of a mail. So the body of a mail has to look like this. This is the name of a recipient, and that is, for example, Nicholas. So we have optionally format is optionally we have a name and a space, and then we have required an address. Recipient and sender. the sender will always be, the recipient will always be called, the gamer. If format first argument is an email address. So this script can have an email address, and the email address will be concatenated with the name gamer. That's fine. Okay, this is the curl version. This was the curl version, and now we want to set the body, and the body is at the moment empty. The server is not empty. The server is something. That's fine. Okay. Now only 2 things are missing. I don't think that we will send an email today. 1 hour is quite heavy. So we try to get a recipient, and then we have to use this. Yes, this here we have changed it already. Missing field. Recipient, yes, that's fine. The recipient, in this case, the sender set. Oh no, this is wrong. The sender is, yes, TGS. Okay, that's interesting. Because the sender is the TGS administration. And we have 2 spaces here, so we have to take the first space from the right side. And this is the delimiter for the name field and the address field. That's the reason why we have 2 variables. Okay. Now we have to get the resource. That is, we want to get the resource. How do we get the resource? No. Main libgaming resource res to vecstring, yes. Resource find, okay. Account creating, so the yes. We try to get the data of the resource, what resource, and this is the resource called. mail verify text in. Whatever. Okay. Dashes as well as dots will be changed to underscores. So this is the name of the resource mail verify text in. If we don't get the resource, then we have to print an error message, and could not find the mail resource. Let's try to make a bug intentionally. Okay. Build native. Unused parameter, yes, of course. Void server. Resource does not name a type of course. Because come on. Res.h. Do I need this in the TGS library? Do I have a TGS library? No, I don't have a TGS library. Why? Okay. So if I execute this function, then we should get an error that the internal mail resource hasn't been found, and this yes, during the process, reason unknown, yes, because we make another function like in the command processing that is called actually I don't like this. It's so cold in here. So, success code. Why is the reason unknown? Because we didn't. We didn't set the reason like here. Yes, whatever, okay. So we make a convenient error function that is called account creating errorlog, and we use this thing here, and we use this thing here as well. Okay, and then because it's a success thing. Success command. I think we don't need this here. Yes, of course, success command is not working. Let's see. Yes, reason. The reason ID. Do I have a response? I don't think so. It's called result, isn't it? Command processing, command create, command decode. The result of a process is stored in REPL in the function result. Result, yes. Response. Reason ID, okay. Reason. Proc, high reason. Proc. No. Okay. Is this fine? I think so, but I want to add this thing here as well. That is the reason, and the reason low level, and this is the reason high level, and there is a reason. I think it's result. What's the result? The result of the process is this thing. Error proc print the response in a success. Here we have this reason. Yes, no. Reason proc. We have to change this here. Yes, perfect. Result reason. Yes. And if we have a reason high, then we... So this reason high is optional. Result proc is fine. Okay. I think this is it. Reason. Oh, we have to retest the whole thing, but okay, whatever. We will see. Now let's recompile the thing, and we should get. Oh, come on! Couldn't find. Yes, of course. Error log. AC error log. Could not find mail resource. Missing field recipient. The main reason has this ID. If this is a member already, we have another high level reason. ID. The first value of this reason ID is unknown, but if we can allocate a log entry, then we can store the log entry into the result. Reason ID, yes, fine, and print the stuff. Yes, cool. Oh, come on, that was not declared. Oh yes, oh no, come on. Lib. Why do we have a log included here? That does not make any sense. Okay, libbsbc. Fine, perfect. Okay, whatever. Okay, it's compiling fine. Now what do I expect? I expect an error during the process execute. What does disabled mean? Disabling the repel disabled. Error during process execution. Okay, let's try this again. Error during process execution. Fine, but could not find mail resource. That's fine. Reason. Proc print. Error process print. Error during process execution. Reason low level, reason high level. I'm confused. Okay, let's see. Yes, because of this. Reason high. Reason high, then we should get rid of these lines. okay, we only have low level, but why don't we get low level? We execute the repel function, tg manually, repel, tgsa repel 0 and forced, and the first one forced as well. Cool. What if we try this again? Could not find process. Yes, that's cool, but okay, that's cool, that's fine. Is it? Yes, that's fine. But we need a low level result. Why don't we get a low level result? Reason. Because we did not read the reason. So, error during process execution, low level stuff, and okay. I'm still not happy with this echo. And then now I think I'm happy. Yes, that's cool. And error during process execution, reason low level, repelling is disabled. So it's still listed here, that's fine. The error had an error because it could not find the resource, that's cool. And now we fix this error by removing the A, the trailing A. Let's see, now the process should run forever. Yes, and that's it. So we have gotten the resource file. Yeah, whatever. Okay. String resource, string mail, string body. Okay. The body is equal to this. Let's see if we can compile this thing. The body is equal to the resource, to the mail resource, and we want to print the body. Proc inf log body s body.c string. Let's see the body, and oh come on, invalid conversion from const resource. Yes, of course, we have to use something else. That is the p source, pointer of the source. This is the resource, and the body itself is located on the source pointer. And the resource we have got is here. That's cool. dear gamer, blah blah blah. Now we want to exchange this thing with something useful, and that is std string code verify code create that's fine. Return x epsilon z. That's perfect. So and I want to replace body is equal to body dot replace xx code xx with this thing. Let's see if this is working. I think there is a function C++ string replace. Yes. Okay. 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 Size p pos pos is equal to body.find. I think there is a find function. Find, yes. Oh, last off. Oh, last off is interesting. Oh, nice. That's a cool function. Oh, that's a very cool function. Didn't know it exists. Oh, this will be cool for our separation of the recipient and sender name and address. And the find function just gives us this thing as size t, and we want to find this thing. And if pos is equal to string and pos no position, then could not find internal code marker. Code. No matching function call for whatever. Replace. Come on, we have a position and what? Oh, come on, length. Oh no. No, come on. Yes, this is static. This has a static length. Oh. Only the easy stuff is implemented. Do we have a smart person? Replace button with another string. Do we have a smart person on Stack Overflow? There is a function to find a substring with a string. Range in a string, another string, yeah. So you can combine those to get the effect you want, yes. Replace. Yes. Okay, whatever. I'm tired. Let's make a library function. The library function will be called void. No, let's make it size t. Is there replace? And we have a no, not const, but we have a std string reference in const std string reference find str in whatever str find or search str search no find. Yes, what do I want to find? Const string reference str replacement whatever. Okay, so this should be what? No, what? Global init, global init. Fine. Let's see if we... Yeah, that's fine. Yeah, okay. So, size t pos is equal to str in dot find what str find return pos and blah. String tail is equal to no if pos is equal to string and pos then return pos. But if we have found this thing, then we can say the tail is equal to str in dot substring beginning at position I found this thing plus the size of the string I have found until the end. It's the tail, and str in is equal to substring starting from point 0 up to length position plus str replacement plus str tail. So this is not working as expected, but we want to change the body and we want to find XX code. XX. And we want to replace it with this thing. And we print the body two times, before the replacement and after it. Could not find yes, could not find internal code marker. Okay, whatever. So let's see if we can compile this. Yes, that's fine. Boy, didn't expect this. Error during process execution, could not find internal code marker. Why? Because in our resource we don't have this marker. We compile this thing again. Oh yes, this is the input with the marker XX code XX. And we have replaced the marker with X. Epsilon Z. That's cool. So we have git add lib dsbc add function as the replace. That's fine. Okay. A lot of work to do. So fine. We are creating the mail sending process. And haha, that's the next step. We have created the body and body. Why posy? And that's fine, dear gamer. This is static stuff, and this is static, and this is created. Needs to be changed in the body, and that's fine. So let's see if we can compile this. Yes, that's fine. Okay. Yeah, that's cool. Okay. Oh, I'm tired. Yes, let's see. Sender set, so server set. We have a server, that's fine. Server is equal to server. Recipient. Yes. So the recipient name is this. We have a size t position. We say position is equal to recipient dot find last of. Please, come on, please, a character. I want to find a character. Yes, one character. Okay. If pos is equal to string and pos, then I want to make it as beautiful as possible. So if this is not npos, proc warning log, recipient address is come on. And the name is equal to name. If this is not npos, then the name is come on, substring from 0 to position, and then I say plus position. The server is from the position. Yes. Yes, that's fine. And I want to have this thing. So I don't want to see the space anywhere. The last space should be deleted. The address is something and the name is something. Yes, hopefully. We make a temporary thing that is this. The recipient name. So what are we sending? Oh, this is wrong. Okay, cool. Yeah. Why? Oh yeah. Oh. Oof. Yes. This is it. Oh, come on. We have two processes. I want to TGSA. No, I don't repel them. I just recompile the stuff. Create. So, that's cool. The address, we have sent this, and the address is this, and the name is this. So that's fine. And now I want to test this case. What is happening here? Yes. No. no segfault or anything. That's cool. Okay, so we have a cool function that is splitting everything we need. So if0, that's cool. Recipient set, and the same for the sender. This is the sender name. And the sender address. Sender. Cool. Should we make a split function? Yes, why not? I'm motivated. Void name address split, and that is const std string reference str in, and then std string reference name and std string reference address. Yep. And then I say name, and then I say str in, and then I say address. That's cool. There is no error, that's fine. I don't know why, but I don't... I want it to be like that. Okay. Name split. What do we want to split? We want to split the recipient into the name and into the address. And we want to split the sender into its name and address. We will test this again. Oh, that's cool. Let's see. Gamer, that's fine. What about this? Okay, that's fine. What about this? Yeah, that's fine too. Cool. So now we need, yes, we need another thing. that's the last thing I implement. That's server and password. We need a password. Okay. Almost. Okay, guys, I think everything is fine at the moment. We have a subject, we have a body, so we said yes, and then we have here password set, and this is the some kind of password, and the password will be read out by the JSON from a JSON file. So we have a server, we have a password, we have a recipient and a sender, we have a subject and a body, and then we can start the process and we can wait for the process to end. And this is done here, and we say m start is equal to m start ms. Yes. M start. Okay, M state. And we have a state where we say mail sent wait. If timeout sending mail, and the mail send timeout ms, count creating error log, that's fine. And this is returning timeout sending mail. That's cool, that's very cool. Sending the mail shouldn't take that long. 2 seconds. Yes, I think this is it. And now the process should end because of the timeout. Why did I compile this thing? I want to remove this exit because now we should be able to end this thing. Oh, come on. Account creating, yes. Who is setting this? What? Hmm? Now I'm confused. I create the process and then it should... Ah, I'm so stupid. Build. No, what? Why? What? Build native, yes. Again, I have a spelling error. It's so, come on. Mason build native. Yes, and build native. Oh, come on. So last minute. What is happening? What is happening? At least it's compiling. This sounds like a strange. This looks like a strange error. Come on. So hopefully there is no memory corruption. Start mail send wait transferring shut down. Closing socket. Yes. start. So this account creating start, then it's creating the mail sending process. Yes, the command processing is repelling the TCP transferring process. That's fine. So I have initializing not used, done processing. This is kind of bad, I think. This seems to be bad. Yes, unused, okay. Ah, come on, no. Yes. Resource body position, This looks very bad. Start. Maybe, hopefully. Please, please, please. Come on, please. Hopefully it's just a copy and... Copy paste error? No. Let's see. State. Start. State. Oh, the fuck. Okay. This is the end of the stream. A strange bug. Okay. Okay. So the state machine seems to be corrupted somehow. Let's check the repelling of the connection. Start mail send temp. I think there is something strange going on. Okay, so nothing is happening. kind of nothing. That's a cool bug. Okay. Oh, come on, the last thing. Yeah, no matter. Okay, doesn't matter. Why the temp? Why temp? Why temp? Why temp? I'm so stupid. I'm so stupid. Okay, no. Whew. I'm so happy this is no memory corruption. Of course it is in temp, because as long as this thing does not get a timeout, it's going through. That's very easy, in fact. So this is the last test. Oh, come on. Yes, silent wait. Yes, we have to clear this as well. Yep. Yes, that's fine. Creating a command create. Time mode sending mail, and now we can remove this exit. Yeah, that's cool. That's cool. Exactly. Exactly what I expected. So now at least we create the account creating process. It's running for a while. It's creating. Let's repel the thing again. The mail sending process is running for a while, as you can see, but then we got the timeout. We return because of the timeout. Then, and yes, we have the error message, timeout sending mail. Error during process execution, reason low level is timeout sending mail. Okay, cool. That was close. So, create this thing, account creating, recipient. No, actually, we don't want this to be called a gamer, at least at this point. And in the account creating thing, we want to be, if we have a recipient, then body recipient. If not a missing field, then fine. Okay. Otherwise, we say the recipient is gamer. Plus this thing. Now we should get we sent an email. Yes, we sent the email office, just the email, and the gaming server just knows about an email. So this gaming server is communicating with the administration server. The gaming server is sending the email address to the administration server, and the administration server calls the recipient gamer. So this information is stored in the administration application. And if we want to change this, then we have to change this in the account creating process of the administration app. This is just how you define the API. So that's fine for me. The recipient. Yes. Oh, yes. Oh. Now, I just want to add one last function because I don't want to forget this thing. And that is bool. Is valid email const std string reference mail. Missing field. If not is valid email Okay. Okay. Let's make something to test. Size t post post is equal to mail.find. We want to find an add. If post is equal to string and post, then return false. So this function is not completely implemented, but we can test. Init statement in selection. What? Okay. So we want to make an add. What? Yes. Exit. So, error during process execution. Recipient not a valid email. Yes. And now, this is very important. Yes. Come on. So it's getting late. So now we have a valid email, at least partly valid, and timeout sending mail. And that's cool. That's cool. Yes, that's fine for me. Okay. So this is it for today. I think a lot. We have reached a lot of stuff again. We have finished the API for the administration server. We have began to implement the account creating process as well as the mail sending process. Next time we only have to add all the curl stuff. And then we should, I guess next time we will get the email sending done. And then the first administration process is finished. We have, how many administration processes do we have to implement? These 4, the account creating process, this is in the game server area. We have an account creating, we have a restoring, a verifying, and a user authorizing process. That means we have 4 processes to implement. And we have to add the class on the gaming server side, which is communicating to the administration app like the test scripts. These processes will implement all the user interacting stuff, like giving the user a menu, showing them a user, hello, you are registering at this server, an email has been sent to your account, you have to put the verification code into the field and then process the stuff. So these processes will on the one hand send information to the user what is going on, and on the other side is they are creating a process which is communicating with the administration app and is therefore an agent for these two peers or sides or parties. Yeah, very cool. I'm very happy, and I'm so happy that this wasn't an memory related issue. Repel. Okay, so everything seems to be fine. So let's see the diff. These files have been changed. It's quite a lot. And we will make a cool commit message that is called all the stuff. I don't care. I'm very lazy in this project with commit messages. Finish API. Test scripts and begin account creating. At least I don't write save like the last time. That's it. Perfect. Okay, so we will be raiding somebody. See you next time. Next time will be on Tuesday next week. This is a cool guy. They're all cool guys. All cool people. JB Peak is coding. Boom Ben is coding. Gräfin is playing something. Rensemmer. Oh, this game is so cool. JS. It's not my world is C++. Let's stick on C++. I think Boomban has a new project. Okay. Oh, and Rensemmer is making ASCII art again. Oh, this is so cool. Look at that. Oh, that's cool. He says this word is too small. He is speaking in German. Let's go to beer class. So see you next time. Thank you for watching, and please raid with me at the pit class. So we have a small group. See you next time. Bye.